Hey, today we're going to do a little dividing decimals review. Last week we learned in lesson 4.4 how to divide a decimal by a whole number. So we're just going to quickly review that here. Dividing a decimal by a whole number, we need to first locate the decimal in the dividend, so that's the number inside the house. And we're going to move it straight up into where the quotient goes. So we have 23.6, here's our decimal, and we bring it all the way to the top floor. We put it right here. And remember to use that graph paper to help your columns stay nice and neat if that's something that you struggle with. So then we forget about the decimal and divide those numbers like they're whole numbers. We now have 5 and 2,360 basically. And we know that 5 can't go into 2, but it can go into 23. So 5 can go into 23 4 times. 4 times 5 gives us 20. We subtract 20 from 23 and we get a 3. So then we've got to bring down this 6. We have 36. So then we ask ourselves, how many times can 5 fit into 36? Well, we know our 5s pretty well. And we know that 5 can go into 36 7 times. So we put our 7 up above where that is. That's where that column would be. 7 times 5 is 35. When we subtract it, we get 1. Well, we can't stop there. This needs to be a 0 if we're going to stop. So we add a 0 and we bring it straight down. 5 can go into 10 2 times. 2 times 5 is 10. We subtract it. Here we finally get a 0. There's no other numbers up here that we haven't used. And so we can go ahead and be done. Our answer to this problem is 4.72. So now today we're talking about 4.6. Now I know we skipped 4.5. We're going to come back to that. But I think 4.6 is better when we do it right after 4.4. Today we're talking about dividing decimals by decimals. So that means we're going to have decimals both inside and outside of the house. And what we need to remember with this is we never want to leave a decimal outside the house. We always want to turn it into a whole number. And so how do we do that? By just moving our decimal point. We can move decimals as long as we move them both inside and outside the house the same distance and same direction. So we have 2.5 outside the house. We don't want that. We want to make this 25, and in order to do that, we need to take this decimal and hop it over one place in order to get it around that 5. We want to turn this into 25 point. That decimal point is still there, but we don't need to put a decimal at the end of a whole number for most purposes. But our goal is always to get that decimal right in here next to the house. So if I took and moved this decimal one point or one place to the right, I need to do the same thing with this decimal in here. I'm going to have to move that one place to the right. So now what I really have is 25 outside the house and 37.5 inside the house. So now we're back to what we did in 4.4. We've got a whole number out here, a decimal in here. We would take our decimal point straight up, and then we would act like it's whole numbers. How many times does 25 go into 37? And so on. So we move the divisor decimal point enough places to the right to make it a whole number. Then we do the same thing inside the house. Put the decimal point straight up and divide it like normal. So let's practice just moving that decimal point. I've got some problems here in which we need to just practice rewriting these problems so the whole number is so the divisor is a whole number. So right now we have 0.7. We don't want a decimal out here, so we need to move it one place to get it right there. If we're going to move that one place, we got to move this one place. And so now we have 7. We don't have to put 0.7, but 7 outside the house, and we have 56 inside the house. How about this one? You try this one. You should have gotten 38 outside the house and 45.6 inside the house. Good job. How about this one? Oh, I have 2. If I move it one place, I still have a decimal here. So in this one, remember you move it until it's right next to the house. I have to go once to get around the 1, twice to get around the 4, and finally I'm where I need to be. So I move it 2 places. I've got to do the same thing here. And so now I have 14 outside, and I have 84.1 inside the house. Same thing here. I'm going to have to move it how many times? 2. I hope you said 2. So when I do that, I go oop, oop, and there we go. That means I have to do that here. Oh, what happens when I run out of numbers? I still have to move those 2 places. It just becomes like our egg carton we talked about. We need to fill it with an egg. So there you go. We've got 25 outside the house, and we have 6,250 inside the house. That's where our decimal point is, right there at the end. Is this one going to be any different? Not really. I just need to move it till it's right next to the house. This time it takes me 1, 2, 3 times to get it here. Oh, what happened to my decimal point here inside the house? It's a whole number, so that means it's at the end, 171.0 if I wanted to put a decimal there. So I'm going to have to still move it 3 times. I'm going to make it 1, 2, 3 little egg cartons I'm going to have to fill in. So I end up with 171,000 inside the house and 38 outside the house. I want you to go ahead and try number 6 and number 7 on your own, and we'll talk about them tomorrow. So go ahead and pause it and rewrite those as a whole number. All right, so let's actually try a problem here. We have 1.3 outside the house, 7.69 inside the house. So we have 7.69 divided by 1.3. We need to divide it, and then at the end we need to round to the nearest tenth. Make sure you're watching the directions. This tells me I need to round to the nearest tenth, which means I only need to get this problem to the 100th place value in order to find out how to round it to the 10th. You should not have a decimal going on and on and on here. So what's my first step? Remember, I never want a decimal out here, so I've got to take care of this first. I'm going to move this 1 place to the right. I got to move this 1 place to the right. So I'm going to rewrite my problem. 13 is on the outside, and now I have 76.9 here. What's my next step? Ooh, if you said move the decimal point straight up, you are correct. So now I'm going to forget about my decimal point. How many times can 13 fit into 76? Well, for some of you, you might need to start adding 13, 13, 13, 13 over here. For some of you, you might know this a little bit better. But I sit there and think to myself, well, 13 times 2 is 26. 3 is 39. Ooh, 4 would be 52. 5 would be 65. I'm getting pretty close. So I know it can fit in at least 5 times. What happens if I go 1 more? What's 65 plus 13? Ooh, 78. That's too much. So 5 is going to be my answer here. I put a 5 up. I'm going to multiply it out. We said it was 65. So now I subtract 76 minus 65. 6 minus 5 is 1. 7 minus 6 is 1. All right, brother says bring down. So I got to bring this 9 down. So now I have 119. Ooh, how many times can 13 go in there? Well, let's see about that. I know that 13 times 10 would equal 130, which is too much. What if I take 13 away from that? 130 minus 13. Well, minus 10 would be 120. And if I took 3 away from that, I would be at 117. Aha! This is going to be a 9. 9 times 13 is 117. That was a pretty good guess. So now when I subtract 119 minus 117, I get 2. Ugh, I'm not done, so I've got to add a 0 and bring it down. Now it says round to the nearest tenth. I can't stop here. I need to find out what this next number is going to be in order to see how I'm going to round it. So now how many times does 13 go into 20? It goes in there 1 time. 1 times 13 is 13. 20 minus 13 is 7. Do I need to keep going? No. I've got enough information now to tell me how to round it. This is where I want to round it to. This, I'm going to change my color here. When we do rounding, remember we underline the place value we want to stop at. and then circle the number that's going to tell us what to do. This 1 is going to tell me that this number is going to stay put. I don't get to change it. So my answer is 5.9. Yay, good job with that one, guys. Now we got a word problem. We just had Halloween, so pumpkins were on sale. Some people are still buying them for Thanksgiving coming up here. What if we bought a 9.5-pound pumpkin for $4.75? Could I figure out what the cost per pound of the pumpkin would be? Of course we can. We just need to set up our problem here. So here's my house. What am I dividing 4.75 out here and 9.5 here? Or is it the other way? It's the other way. I want $4.75 in here, and I'm 9.5 pounds here. So that'll tell me what is my cost per pound. I want to divide it by pounds. So I don't want to leave 9.5 out here, so I'm going to have to move my decimal one place. So now I have 95, and then I have 47.5. So I got to move my decimal straight up, and then I can start dividing. Can 95 fit into 447? No, I don't have enough. If I had 47 cookies, I couldn't divide it evenly among 95 friends. So there's not going to be anything here. If you want, you can put a 0 in here. But we need to move over and count it as 475. So if I have 475, could I divide it? Absolutely. I'm going to think to myself that this 95 is pretty close to 100. So how many times can 100 fit into 475? Well, I know it can fit 4 times. Can it fit that 5th time? Do I want to try it? I'm going to gamble. I'm going to say 5 times because I know this isn't quite 100 and this is almost 500. So I'm going to say 5 times. We'll see if this pays off. So now I got to multiply. 5 times 5 is 25. So I put my 5 down and my 2 up. What's 5 times 9? 45 plus 2 is 47. Look at that. It paid off. What happens when I get 475 minus 475? Nothing. And there's nothing more to bring down. I am done. So 0.5 is my answer. What's my question? What is the cost per pound of the pumpkin? Well, is 0.5 an answer? 0.5 of a dollar is 50 cents. So I want to make sure with our dollars and cents, we go to the hundredths place. So I want to say 0.50 is the cost per pound. So 50 cents a pound, a 9.5-pound pumpkin is going to cost us $4.75. Good job. All right, here's 2 last ones for you. I want you to go ahead and try them. Remember, the first thing you need to do is get rid of that decimal outside the house. So you need to rewrite the problem, making this a whole number and this a whole number. Remember, however many places you move the one outside the house, you have to move the decimal inside the house the same amount. Good luck, and I'll see you in class tomorrow. Have a great night.